Good morning students, welcome to the next class of switching theory and logic design. In this class we are going to learn about the study of ICs, that is 7442, 7447, 7485, 74154. So here we are presently discussing the unit 3. In this unit 3 we are learning about combinational logic circuit design using MSI and LSI. So up to now we have studied the different types of combinational circuit operations. So in this class we will see those operations by using MSI, medium scale of integration, and LSI, large scale of integration. So this is nothing but as we will see all the circuits with the help of some integrated circuit standards. Okay, well, now we will see all the basics of those circuits with using ICs. So these are the standard IC numbers for that some of the functions. So coming to see here, what are they? So here we have 4 ICs, that is first one IC 7442 and IC 7447, IC 7485, IC 74154. Coming to the first IC 7442. So this is the IC 4 line BCD to 10 line decimal decoders. Here we will give the binary coded value, that is in terms of 0002 and 1001. So here we have totally 10 input combinations, that is our BCD values 0 to 9. So we are representing 0 to 9 in binary. So those binary values we are giving, and it will give the 10 output decoder. If you select one combination of input, it will select one output. It will select only one output at the decoder side. Okay. So this is the first IC. Next, coming to the second IC, IC 7447. So first we will see the first IC. So see here, 7442, 4 line to 10 line decimal decoder. Right here. Right. So see here, it is nothing but as 4 to 10 decoder. Actually, we know that some standard decoders, that is 2 to 4 decoder, 3 to 8 decoder, and 4 to 16 decoder. So these are the some of the standard decoders. But this decoder is 4 to 10 decoder. 4 to 10 decoder. Here we know the standard. We know that the 2 to 4 decoder means 2 inputs and 4 outputs. Here 4 to 16 decoder is 4 inputs and 16 outputs. Now coming to here, this is 4 inputs, 10 outputs are available in this particular logic function. These 4 inputs are BCD inputs. That is, here you can take the inputs are 0000, 0001, 0010 up to 1001. So these are the total 10 combinations, and here I am giving these inputs are ABCD. So see here, this is the IC diagram. In this IC diagram, so these 4 are the inputs. These 4 are the ABCD inputs. These 4 are the ABCD inputs. Next, coming to that, for each and every IC we have, for each IC we have the power supply pin VCC, and the ground pin is here we have, that is the 8th pin. The 8th pin is the ground pin, and 16th pin is the VCC, and this is the 16 pin IC. This is the 16 pin IC. Coming to the 16 pin IC, here we have 0 to, so 0, 1, 2, 3, 4, 5, 6, 7, and so see here after 7 we have 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally 10 outputs. So these 6 and these 3. Total, these are the outputs. These are the outputs. These are the outputs. These are the inputs. Okay, ABCD 4 inputs, right? So four inputs, 10 outputs, 1 VCC pin, 1 ground pin. Total 16 pins. Total 16 pins. Okay, so this is the 16 pin IC. Right? Now let us see the internal Let us see the internal diagram of this IC 7442. IC 7442. So let us come to here. Here we have, this is a pin diagram, this is already we discussed just now. So this is I have kept aside. So remember one thing, 4 inputs, 10 outputs. So here see, so this is a first input. So this is a first input, second input, third input, fourth input. Input A, B, C, D, right? Input A, B, C, D. 4 inputs are available, and coming to the 10 output combinations. So 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. These are the total 10 outputs. Okay, so coming to here, how we developed these combinations. For example, if you want to represent output 2, so output 2 we are representing like this, 0, 0, 1, 0. So these are the combinations we have used, 0, 0, 1, 0. So these are the input combinations we are giving. A, B, C, D we are giving in this way, right? A, B, C, D we are giving, that is 0, 0, 1, 0. So this is we are giving at the input combination. This is 0, this is 0, this is 1, this is 0. Okay, 4 inputs are I am giving. So these inputs are processed into the circuit and it will generate the output. It is very simple thing. Previously we did binary to BCD converter, Okay, so at that time we have seen, so the binary values and BCD values are both are same from 0 to 9. After 10 we are representing BCD value as 4, that is, so see here, 0 to 9 for BCD and for binary both are same. So this is binary and this is BCD, both are same. So coming to the 10, we are represented here the BCD values like this, 0, 0, 0, 1 and 0, 0, 0, 0, 4 zeros. And coming to here in the binary, we have represented 1, 0, 1, 0. So this is the 10 representation in binary and this is the 10 representation in BCD. Okay, only that is the difference. Okay, so that is the BCD values. Okay, so here we have the maximum possible combinations from 0 to 9. So for that reason, by using ABCD inputs, you can give 0 to 9 combinations. Other than this, you can't give. Okay, you cannot give. So here, this is a decoder. This is the decoder. It is nothing but a decoder. Here we are not doing any conversion operations, binary to BCD or BCD to binary. These conversions we are not doing here. It is a normal decoder. The first decoder output is A bar, B bar, C bar, D bar. The second decoder output is nothing but as A bar, B bar, C bar, D. And third decoder output A bar, B bar, C, D bar. Like that we have the operation. So this seems to be like as a 4 to 16 decoder, but here we have only 4 inputs and 10 outputs. 10 outputs. So that is D0 to D9 is available. From D10 to D15, these outputs are not available in this IC. That is the very simple IC. This type of ICs we are using for constructing the 7-segment displays. This type of ICs we are using for constructing the 7-segment displays. Okay. Otherwise, you can use for decimal representation. For decimal representation, you can use this type of decoders. So this is the not complete circuit. It is a just a decoder part. Okay. Right. Right. So this is about IC 7442, IC 7442, IC 7442, 7442. Okay. Right. Next, coming to that, IC number 7447, IC 7447. This is the IC BCD to 7-segment decoder or drivers. It is nothing but as it has totally 4 inputs like BCD. So see here, here we have mentioned that these are the BC inputs and these are the AD inputs. Totally here we have inputs A, B, C, D. 4 inputs are available. So BCD to 7-segment decoder, that is BCD inputs are 000 to 1001, that is 0 to 9 we are giving as the input. And coming to here, 7-segment decoder. Generally for 7-segment display we have 7 outputs, A, B, C, D, E, F, G. Okay, so in between this input and outputs we have AND gates and OR gates. Okay, those AND gates and OR gates, there is no necessity of constructing the diagram, logic diagram. There is no necessity of connecting the logic diagram. Everything will be readily available. Just to bring this IC 7447 and just bring the IC, bring the LED display, 7-segment LED display. Here you have 7 outputs. These 7 outputs you can connect to the 7-segment display. So see here, these are the inputs, and coming to here we have the output, that is small a to small g. Totally 7 outputs are available. So 4 inputs and same way 7 outputs. Okay, next coming to that, 1 VCC and 1 ground. Totally 7 plus 4, 11, 11, 12, 13. Totally here we have 13 pins. So this is the 16 pin IC. This is the 16 pin IC. In this 16 pin IC, we have used 13 pins. Okay, totally 13 pins we have used here. And coming to remaining 3 pins. So that is RBI, RB0 and lamp or test. Here the vendor, otherwise the manufacturer, they provided 3 different signals to test this circuit, and it has given some of the controls. What about these controls? If you want to learn about these controls, you have to study the data sheet of this IC. So here the most interesting part is the data sheet. So coming to see here, so these are the 4 different data sheets. So see here I have shown these 4 sheets. I see 7442, 7447, 7485, 74154. First we will open 7447. Why? Because we are seeing this concept. All the data sheets are available. These sheets I will forward it to you. Okay. So see here, this is the IC 7447 data sheet. In this data sheet, here we have the pin diagram. So this is our pin diagram. Okay, is it visible to you? So this is our pin diagram. Okay, this is our pin diagram. So in the data sheet they will give the pin diagram, and generally when a manufacturer is designing different types of ICs, generally he will use different type of significations. Nearly 4 to 5 different types of ICs, they will follow this procedure, this pin configuration they will provide. Okay, next coming to here. So this is about the IC operating condition. So at what temperature? So see here. At what temperature this IC works? So see here, supply voltage you can give 4.75 volts, that is the minimum. So maximum voltage you can give 5.25 volts. You can see here clearly. So 4.75 volts and 5.25 volts. So this is the minimum and maximum. These are the minimum and maximum operating values. And coming to that, the temperatures, at what temperature it will work. So see here, the temperature it will works up to 70 degrees centigrade. Up to 70 degrees centigrade temperature environment, it is ready to work. And coming to here, the electrical characteristics. So the electrical characteristics, when you are learning the digital IC application subject, at that time you will get via IO here, IOL, IIL, VIL, like that you have that some of the voltages and currents. So the currents at low level logic with a high voltage, output level low level voltage, output level high level voltage, input level low voltage, input level high voltage. Like that you have some of the parameters. These parameters we will discuss in our 3rd unit. Next coming to here, we have some of the operating conditions for the each and every IC they will provide. So coming to this is the truth table. So see here, this is our truth table, our function table you can call. So ABCD inputs are given. So input conditions 0 and 1 they mentioned as LH. So see here, you can see the LH combinations. So see here, ABCD, right? ABCD. So actually, this IC is active low pins and these IC output pins are active low output pins. So inputs I am giving 4 zeros, that is low, 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 low. And coming to the output combinations, G is going to high and remaining all the outputs are going to low. So that is nothing but as when it is 0, it is in the working condition. When it is 1, it is not in working condition for active low outputs. So for the active low outputs. So that is we have mentioned already. So see here. So in this IC, see here, these are the active low outputs. I will show again. So see here, these are all the output pins are here, active low output pins. So 7447, first, second, third. These are total 7 output pins. All the 7 output pins are active low output pins. Okay, so based on the active low output pin, this is the circuit diagram for BCD to 7 segment display. Actually, we have to draw this type of diagram, but there is no necessity of drawing this type of diagram. Why? Because the manufacturer or vendor, they have given this type of diagram in their data sheet. So just now we have seen the data sheet. In the data sheet, they will give the internal architecture of that diagram. Okay, right. And this is then our normalized pin diagram. For this pin diagram only, here we have the internal architecture. Right. Next, coming to that, IC 7485. IC 7485 we have seen in the last video. So that is nothing but as it is a 4-bit magnitude comparator. It is a 4-bit magnitude comparator. For a 4-bit magnitude comparator, it is nothing but as it comparison two values. So for example, take A and B. A is consisting of 4 bits, that is A0, A1, A2, A3, and B is consisting of B0, B1, B2, B3. So see here, A0, A1, A2, A3, B0, B1, B2, 3. All the data inputs are we have mentioned here. So these are the all the data. So these are the all the data inputs, So this is the power supply, and this is the ground pin, and this is the ground pin, and here we have A less than B, A equal to B, A greater than B. So these are the 3 finalized outputs. A less than B, A equal to B, A greater than B. So this IC is nothing but as 4-bit magnitude comparator. This is the 4-bit magnitude comparator. So it will compare 4 bits and it will give the output. For example, if you want to compare 8 bits, but here we have only 4-bit comparators. So take 2 4-bit comparators. So you have to first compare 4 bits and give the result to the second 4-bit comparator with using cascading inputs. By using cascading inputs. So the first IC will give A less than B, A greater than B, A equal to B outputs. Those outputs you have to connect here. So for this IC, you have previous 4 bits outputs, that is comparison output, and here you have the present 4 bits of information as an input. So after this, these are the things you are comparing the outputs. So totally here we have these pins. So totally here 8 pins are the present inputs, A3, A2, A1, A0, B3, B2, B1, B0. So those are the 8 input pins. With this we have 3 input pins. If you are using the big comparator, 8-bit magnitude comparator or 16-bit magnitude comparator, but you have here only 4-bit magnitude comparator. So this 4-bit magnitude comparator output were given to the another 4-bit magnitude comparator. So these outputs were connecting to that comparator input. So that inputs are cascading inputs. So these are the cascading inputs, and remaining 3 are the outputs, normal outputs. After comparing these 2 values, you will get the comparator output. And next, 1 ground pin and 1 VCC pin. And here we have, so total see here, 8 plus 3, that is equal to 11, 11 plus 3, 14, 14, 15, 16. Total 16 pins are over. Total 16 pins are over. So this is the 16 pin IC. IC 7485 is the total 16 pin IC. So see here, A0, A0, B0, A1, B1, A2, B2, A3 and B3 is here. B3 is here. This is the data input. Now let us see the internal diagram of the 4-bit magnitude comparator. This is our general IC. Coming to here, this is the comparator circuit. Okay, you can see this comparator circuit from our last discussion. So in the last discussion I have given the same type of diagram. So see here I have used an AND gate. So this is the A equal to B combination. This is the A equal to B operation. When A equal to B operation will be done here, it will check the A is equal to B bits. That is when A3 B3 bit is equal to 1 and A2 B2 bit is equal to 1, A2 A1 B1 is equal to 1 and A3 B3 is equal to 1. That is if A3 is equal to B3, then A2 is equal to B2, then A1 is equal to B1, then A0 is equal to B0. Then only this AND gate goes to 1. That is nothing but as A equal to B operation we will get here. We will got here. And remaining the above circuit is A greater than B and the below circuit is A less than B. These internal structures already we have discussed in the previous classes. These internal structures already we have discussed in the previous classes. Okay, so you have to study this circuit. Here I am not ready to explain the concept again. Already we have discussed this concept. So go to the previous lectures, lecture number 49 and 50. Okay, 49 and 50. From that lectures you will get these combinations. And the last one IC 74154. So this is one more IC in our subject. So this IC is nothing but as it will give the 4 line to 16 line decoder. It is nothing but as 4 to 16 decoder. 4 to So this IC functionality is nothing but as IC 74154. This is the 4 to 16 decoder. 4 to 16 decoder, right? Otherwise you can use this one as multiplexer also, in sometimes demultiplexer also. Okay, presently see here, this is the circuit which is representing 4 to 16 line decoder or demultiplexer. So see here, you have 0 to 10. Total 10 outputs. Here we have total 0 to 10 outputs and 11 to 15 the remaining 5 outputs. Okay, 0 to 10 11 outputs, 0 to 10 11 outputs and 5 outputs. Totally 16 outputs. For 4 is to 16 decoder the outputs are 16. So here totally 16 output pins are available. 16 output pins. Next coming to that inputs. Here actually we have how many inputs? 4 inputs. So A, B, C, D, 4 inputs are available. So 16 plus 4, right? 16 plus 4, 20 inputs. Actually this is the 24 pin IC. This is the 24 pin IC. In this 24 pins, 4 plus 6, 20 over, and one is ground and another one is VCC. 22 pins are over, and here we have 2 more output pins, that is G1, G2. These G1, G2 are nothing but as the enable signals here. So generally for 4 is to 16 decoder we have the enable pins. That enable pins we have represented here. Other than this, so see here, all the outputs here, all the outputs of here are active low outputs. These outputs are active low outputs. These are not active high outputs. All the industry persons, they are giving these ICs with the active low output signals. So these are the active low output signals. Okay, note it down. You can note it down from here also. So this is a IC pin diagram, just what we have discussed up to now. Okay. Next coming to here. This is the internal logic diagram for 4 to 16 decoder. This circuit diagram already you have drawn in the previous classes. 2 to 4 decoder, 3 to 8 decoder. In the same way you have drawn already 4 to 16 decoder. Okay, that 4 to 16 decoder diagram is there, but it has two more control signals, that is G1, G2. So this G1, G2 are the two more control signals. Totally for each AND gate there are nearly 5 inputs are available. 4 inputs are normal ABCD inputs and another input is nothing but as we will get the combination of G1, G2. See here you have an AND gate with bubble symbol. So here G1, G2 combinedly we are giving as a control signal for all the AND gates. So see here, this is active low outputs. After AND gate you have bubble. So that is you will get active low output signals. Okay, for each NAND gate we have 5 inputs. So in the 5 inputs, 4 are the ABCD normal inputs and the 5th one is nothing but as enable signal. 5th one is the nothing but as enable signal. It is controlled from the G1 and G2 expressions. G1 and G2 expressions. Okay. So this is about the total description and the details of the ICs, and coming to here, these functionalities. So this is the IC 74154. So this is the IC pin diagram. Just now we have seen. This is a pin diagram we have seen just now. See here, this is the pin diagram here we have. In this pin diagram you can see the pin description. This pin diagram only we have given to, this pin diagram only we have given to the, we have kept in the PPT. So everyone remember one thing. For these 4 pin diagrams, you have to draw the pin diagrams. Okay, these pin diagrams you have to note down perfectly. IC 7442, IC 7447, IC 7485, IC 74154. These 4 pin ICs is very very important. You have to draw. Anyhow, you have the switching theory and logic design laboratory in our curriculum based on our J2 syllabus. In that syllabus, you have to use these ICs. You can check the functionalities of these ICs. And coming to that, internal circuit diagram. And these are the again common operating voltage, at what temperature it is ready to accept, and what are the maximum voltage and what are the minimum voltages we can give. And this is about the function table. I said that, so see here in this table all the H values are, you can see here. You will get all the H values and you can see here. So we know that for all the decoders, here L is there, here L is there, here L is there, all the L's are available. So it is nothing but as, we know we can give the clarity from this table. Only one output will be activated and remaining all the outputs are deactivated for the input, for any input combination. So this is the situation here. Okay. Right. So this is about the function table. Next, coming to that, this is the logic diagram. This logic diagram only we have kept in the PPT, just what we have seen. So this is the logic diagram. Okay, so this logic diagram is nothing but as, it has 4 inputs, 16 outputs. In 4 to 16 decoder, internal logic diagram. Okay, and coming to that, when you are implementing this hardware by using different types of functionalities, for that they given the pin description. So see here, these are the pins they given at the side, and for the each pin how much thickness is there and how much width or length are available. So each information they given. So see here. So this is about the pin description. So when you are taking that IC, so see the IC from the side view. So from that side view, you can see the IC description. These are the stainless steel metal pins for the IC. Okay, and IC thickness, IC color, and IC total IC dimensions they have given here. Okay, And this IC, once the company person manufactured, you cannot modify the functionality. If it is there, you can use. Otherwise, you cannot use that IC, right? So that is the IC specification. When you manufacture this IC, you cannot modify the functionality. So see here, this is one more package. This package has pins side like this, okay? Right, like wings of a bird. Okay, with this we have completed this first part of this third unit. In this third unit we have learned about decoders, encoders, multiplexers, demultiplexers, and we have implemented higher order decoders using lower order decoders and higher order multiplexer using lower order multiplexers. Like that we have implemented all the functionalities, everything about the combination of circuits. Right, thank you.